Okay, right. So thanks everyone. So this is the official announcement of the class. We are going to start class, and the entire session is science and technology. And let me make you understand what actually we need in science and technology. So as a whole, if we talk about the science and technology, so the importance of the science and technology in films, roughly around 8 to 10 questions, means approx 8 to 10%. This part is significant in films nowadays. If you see the trend of this particular topic, especially 2012 onwards, so approximately 8 to 10%, somewhere it is 12%, somewhere it's 8%. So we are just taking average. So approximately 10%, this part is significant in UPSC prelims. And then again, if you just look at this part in mains, so in GS paper third, GS paper third, approx 50 to 60 plus minus 10 marks. Right, sometimes it is even 40 marks, sometimes it is 50 marks, but usually this contribution is 1/4 of GS paper third, 50 to 60 marks, we can get question directly, indirectly from this particular part. So this is quite significant, this is quite relevant nowadays as per the current the syllabus of the current perspective of the UPSC. So what actually the science and technology, before coming to, because this is the first introduction, so what actually we need in science and technology. So usually when we talk about the science, so that is going to sound like it's a concept of physics, chemistry and biology. But as per the UPSC perspective, this is the science and technology, means the importance of this physics, chemistry and the biology in daily life. So on the basis of last 2025 years question paper, we have designed this entire science and technology that also includes general science and its application aspect. Means when we talk about in UPSC paper first, means in UPSC paper, prelims paper, it is mentioned as, in syllabus it is mentioned as general science with application. While in mains it is mentioned as technology with special reference to, there are few names. So as a whole, we have simply clubbed all, whether it is the part of prelims and the mains, and we have designed and we have fragmented the entire science and technology in different heads. And these heads are life sciences, that is the applied biology, means application of biology in daily life. Human physiology to some extent, means the application of the modern technology, modern medical science, modern technology in the human aspect. Again, biotechnology, that is the most significant aspect these days. Health issues, that is the most significant aspect these days. Disease, like in the current, corona pandemic, we are just talking about. In the current corona pandemic, we are talking about so many aspects, like, see, whether we are talking about the strengthening of immunity, whether we talk about vaccination process, whether we talk about the different strengths of the COVID-19. So these entire discussions we are going to do somewhere in the health and the disease. Clear? Fine. Then the next part would be the nanotechnology. That is also most significant aspect, because this 21st century is dedicated for this nanotechnology. Clear? Fine. That is the emerging technology. Again, nuclear technology. Fine. So in the nuclear technology, we need to discuss a lot apart from the conventional aspect, means the concept of the nuclear, the concept of the nuclear reaction, the concept of the nuclear reactor, the component of the nuclear. What I'm writing is not visible. Hello everyone. Just please confirm me. Please confirm me. I'm just writing something. I'm just writing something. Please confirm me whether you can see. I'm just changing all PPTs. I'm changing PPTs. See, I'm just marking. I'm just marking. This is the PPT number 1. I'm just marking number. PPT number 1. Right. This is PPT number 2. I have marked. So please confirm whether you can see these markings or not. Clear? We are going to start this first topic. Means as a whole, we are going to continue these 5 topics as a whole. Life sciences, human physiology, biotechnology, health issues and disease. These 5 topics we are going to club for the next 13-14 lectures. Clear? So, see this life science. The first is the life science. Clear? And here, the required material is what actually is required for the studying. So, if you are going to appear this year, so you don't have enough time. So, better you must be banking about the classes and whatever you got information in the current affairs, because you don't have time for this attempt. But even if you are preparing for the next attempt, in that case you have enough time, and in that case you should go for the basic discussion material as a class 9th and the 10th NCERT is required for the basic discussion. Clear? The study material that you must be getting through the ALS. We have a good designed study material, Science Reporter magazine, and the Hindu weekly edition, means one page of the Hindu is dedicated for all current information which is required as per the norms of the UPSC. Right? So these are the suggested reading from my side. Clear? But we are going to cover all. If you are going to appear in this year, we are going to cover all in these live sessions, what we are going to continue. So right from the beginning, this is the lecture number 1 officially, and see, when we talk about the life forms, so you must be knowing about the basic unit of the life is what? It's a cell. It's a basic concept, right? And you must be knowing about when we talk about the cellular hierarchy. So I am not doing anything that is the rocket science. I am just trying to refresh your class 8th or 9th concept. So you must be knowing about the basic unit of the life is what? It's a cell. Then cell leads to the tissue. That is a number of cells that works together. Then a number of tissues that leads to the organ. Clear? Then the organ leads to the organ system, and finally organism. So we are the best example of the organism. And see, you just put yourself here at the position of the organism. So the basic unit of the life is what? It's a cell. And you must be knowing about, when we talk about the basic unit of the life is cell, so there are 2 different categories of the cells. One is prokaryotic cell, and the second is eukaryotic cell. Right? Fine. So we need to consider only 2 forms of the hierarchy. One is the cell, which is the basic unit, and the second is the top of this hierarchy as an organism. Clear? So at the level of cell, we have 2 different categories of the cell, like the first is the prokaryotic and the second is the eukaryotic, and at the level of organism, we are going to discuss a lot about this organism. Organism that stands for the life forms. Clear? So let me take one by one. One is we need to consider the cell, and the second is we need to consider this organism. So at the level of cell, we have 2 different categories of the cell. One is prokaryotic cell, and the second is eukaryotic cell. Right? The difference is what? This prokaryotic cell and the eukaryotic cell, it is very clear from the term itself, this PRO, that stands for primitive. So this cell is evolutionary primitive, while the word EU, that make a sense of the advance, means this cell is evolutionary advanced. Clear? So at the level of cell, we have two different types of the cells. One is the prokaryotic cell, which is evolutionary primitive, and the second is the eukaryotic cell, which is evolutionary advanced. Right? Fine. This is the first unit of the hierarchy that we have mentioned as a cell. We have two different types of the cells. One is the prokaryotic cell and the second is the eukaryotic cell that we have mentioned on the next page. Clear? So this we have considered. Again, we need to consider this organism. Otherwise, we need to leave all tissue, organ and the organ system. This much of the static information is not required. That's why we are leaving. Right? So when we talk about this organism, clubbing this organism on the next page here, at the level of organism, we have different organisms. Like one organism is monera. This is the group, means it's a bacterial group. It's a bacterial group. So monera organism, monera has prokaryotic cell. So when we talk about the bacteria, when we talk about the monera, it means we are talking about the cell as a prokaryotic cell. Means whether we talk about the, whether we talk about the harmful bacteria, like see nowadays we are talking about the pneumonia is a symptom in the case of the COVID-19. So what actually the relevancy of this pneumonia-like symptom in the case of COVID-19, I will let you know, I will explain later on. But when we talk about the pneumonia itself is what? It's a bacteria. When we talk about the tuberculosis, that itself is a bacteria. So whether we talk about the harmful bacteria, like the disease-causing bacteria, or whether we talk about the, useful bacteria like the lactobacillus in curd. So whether we talk about the positive or negative bacteria, means all bacteria belong to this group as a monera, and as a whole, monera means we are talking about the group of organism with the prokaryotic cell. Means all bacterial diversity have prokaryotic cells. Means when we talk about the prokaryotic cell, the best example of the prokaryotic cell is nothing but bacterial diversity. Whether we talk about the cyanobacteria, means blue green algae, whether we talk about the normal bacteria, whether we talk about the Archaebacteria, means bacteria means prokaryotic cell. Clear? Again, we are talking about, this is the first level of organism. The second level of organism is protista. It means we are talking about here, the best example is protozoa. Yes, amoeba, paramecium. This is the second example. Third organism is fungus. Yes, best example of the fungus is what? It's a mushroom. Best example of the fungus. Yes, fourth group of organism is animal. Animal. We are the best example. And in the animal, whether we talk about the non-chordates or chordates, means invertebrates or vertebrates, right from the scratch of miniature in animal kingdom till the highly developed animal like the human. We need to put in this particular term like the animal. So animal means either we are talking about ourselves as an animal, right, or we talk about the mosquito as a good example of animal. Means we all animal diversity we need to keep in this particular term, that is what it's an animal. And the fifth group of organism on the earth is what? It's a plant. plant. So on earth we have 5 different forms of organism. One is the bacterial diversity, which is put in Monera as a group. The second is protozoans, which is put in Protista. Third is fungal diversity. Fourth is Animalia diversity, and the fifth is the plant diversity, right? And in the term of cell, when we talk about all these, so this Protista, whether we talk about Protista has eukaryotic cell, fungus has eukaryotic cell, Animalia has eukaryotic cell, and this plant has eukaryotic cell. Right? Means amoeba, paramecium, all eukaryotic in nature. Fungus, when we talk about the mushroom, or when we talk about even the yeast, which is used for the fermentation, is eukaryotic in nature. Whether we talk about ourselves, we are the best example of the eukaryotic cell organism, and the plant itself is the best example of eukaryotic cell organism. Right? So on the basis of cell, we have 2 categories of the cells. We have just started. This lecture number 1 is the life forms. And even I told you, here it is mentioned as the basic unit of the life form is what? It's a cell, right? And when we talk about the cellular hierarchy, the cell, tissue, organ system and organism, and what we have done so far means that was not visible to you, but simply I am summing up. We need to consider only these 2 categories, means at the level of cell we have 2 categories of the cells, and at the level of organism we have 5 categories of organism, and here we have summed up this cellular hierarchy like this. Means at the level of cell, what we have done so far, at the level of cell we have 2 categories of the cell, like the first is the prokaryotic cell. We need to start from here itself. And this cell is evolutionary primitive, and then the evolutionary advanced cell is the eukaryotic cell, and at the level of organism we have total 5 categories of organism on the earth. One is the Monera, that consists of bacterial diversity, and this is prokaryotic in nature, means the cell of bacterial diversity, means the cell of bacterium is prokaryotic in nature. Otherwise the rest of the groups of organism on the earth have eukaryotic cell, like the Protista, fungus, Animalia and plantain. Means the entire organisms on the earth have been categorized into the 2 categories of the cell. One is the prokaryotic cell and the second is the eukaryotic cell. Bacterial diversity is the best example of the prokaryotic cell, while the protozoan diversity, fungus, Animalia and the plant diversity are the best example of the eukaryotic cell. This is the briefing of the discussion what we have done so far. So officially we are supposed to start from this entire discussion. So before proceeding ahead, you just let me confirm whether you are getting my sound, whether you are getting this PPT or not. Just confirm it, then we are going to proceed. Please do it fast. Okay, fine. So, fine. Okay. So, listen. See, if you just look at, if you see here, this is the evolution of life on earth. This is direction of evolution on the earth, and this we are talking about evolution on earth, and you must be knowing about the age of earth is approximately 4.6 billion years. This is the age of earth, and this is the direction of evolution. Means from the primitive stage we are heading towards the current stage. Clear? And you must be knowing about, initially there was no life on earth. no life on earth. Clear? And that was replaced by first life on the earth. So those no life was replaced by first life on the earth, and this life was prokaryotic life that we placed in the kingdom Monera, and this is nothing but it's a bacterial life. Right? Fine. So from the no life to the life condition, that was the first life and it was the bacterial life. Clear? Then again in the process of evolution, what happened? This prokaryotic cell was upgraded into the eukaryotic cell, and this eukaryotic cell was unicell. Means prokaryotic cell is always unicell in nature, and this prokaryotic unicell cell was upgraded into the eukaryotic cell, and that was also unicell. And here was the emergence of the second group of animal, and this was placed in the kingdom Protista, and here the best example is protistans. Best example is the protozoans. So here in protozoans we could place here the best example as a amoeba. Best example. Clear? So the first life that was emerged on the earth, that was the bacterial life, was the Monera, that was upgraded into the protestant life, right? That is the best example is what? It's a protozoa. That is the one example that we have placed here. Apart from this, there are so many other examples that we are not supposed to put here. And then onwards, protozoa onwards, life trifurcated in three directions. Means see, this eukaryotic unicell organism was upgraded into the multicell. Means life became eukaryotic, but now this unicellularity became multicellularity, and the life was trifurcated in three directions. The first direction was plant, third form of the life. The second direction was fungus, that is the fourth form of the life, and the fifth form of the life, that is the animal. This is the way how life evolved on earth. Right? This is the way how life evolved on the earth. The first life was bacterial life. Clear? That was emerged on the earth. And this bacterial life was prokaryotic life. This bacterial life was upgraded into the protestant life, and the protestant life was eukaryotic unicellular organism. And from protista onwards, life trifurcated in three different directions. And the one was the planty life, second was fungus life, and third was animalia life. And these lives were multicellular and eukaryotic in nature. Fine? Okay? I hope there is no technical problem. Getting audio and visual properly? All good, right? Thank you. Fine? Okay. So, see here, again, see, we are simply considering here, the entire forms are life forms. And the life forms emerged from no life. Why life forms? Because all life forms are cellular in nature. When we talk about the life, the unit of life is cell. Unit of life is cell. Clear? And the entire life emerged from the no life condition, because the condition was not conducive for the sustenance of the life on the earth. right? In between, you know what happened? What happened in between life and no life form? There was a transition, interlinking step, and this interlinking step was the linking step between no life and the life form, and this was nothing but it's all about the viruses. So when we talk about the viruses are nothing but the connecting link between no life and life. Right? Viruses are connecting link between living and non-living. Living means life and non-living means no life condition. No life condition, right? And nowadays the entire world is talking about, is crying about the corona pandemic. You see the case of India, and every day we are going to report more than 3.5 lakh cases of corona infection. So here corona is a great example of the virus we are talking about, right? So why we are talking about this entire discussion as a static part? Because we need to see the placing of corona where exactly this virus is there, because the corona is the best example of the virus, right? So when we talk about the virus, it means viruses are connecting link between no living means no life means non-living and living, right? So straight way we are coming to this part of discussion as a virus. Clear? Viruses are known as living chemicals. Viruses are known as living chemicals because viruses are connecting link between non-living and living. So the point is that why non-living? Why non-living? That is the remarkable point, because there is no cell. There is no cell. Why non-living? Because there is no cell. Because when we talk about the life, the basic unit of life is cell. And in the case of viruses, we don't have any example of cells like prokaryotic and eukaryotic. Means viruses are non-living because of this condition, that is the no cell, and this condition is also called the acellular. Viruses are acellular, means no cell condition. Right? But the question is why living? Why living? This pen is non-living because this pen is acellular in nature. Acellular in nature, and even this pen is also static in nature. That make a sense of this is non-living in nature completely. Fine. But when we talk about the viruses are living in nature. Apart from the non-living condition, viruses are also living in nature. And why viruses are living in nature? Because of multiplication. Viruses can multiply. See the communication of the virus. And nowadays we are talking about the different modes of the communication of the viruses. Fine. This is because of the multiplication of the viruses. This is because of whether it is the touch multiplication, which is the touch communication, or whether it is the air transmission. So for transmission, there must be the n number of viruses, right? There must be the number of viruses, and the number of viruses could be possible because of the multiplication. So this pen is completely non-living because this pen could not multiply by its own. But when we talk about the one virus could multiply, and that leads to a number of viruses. So this multiplication tendency of the viruses are responsible for the living nature of viruses. And this multiplication nature of means why viruses are able to multiply. That is also the remarkable part of the discussion, right? So viruses can multiply only because viruses have genetic material. right? And this genetic material is what? It's a DNA and RNA. It's a DNA and RNA. So viruses can multiply because of DNA and RNA. This pen is non-living because this pen is acellular, no cell, and even this pen does not have any genetic material like DNA and RNA that make a complete sense of non-living nature of this pen. Right? So like the same, viruses are non-living because viruses are non-cellular or acellular in nature, but viruses can multiply because viruses consist of genetic material as a DNA and RNA, and genetic material is the multiplication, means the genetic informations are hidden in these two genetic materials which we call as a DNA and RNA. So this presence of DNA and RNA is the basic nature for the determination of the living characteristics of the viruses. Right? Fine. So I hope you are getting my audio visual properly. This is the first class, that's why I am asking, I am much concerned about, because you don't feel panic, right? So I think you are getting this audio and visual properly, what I am writing properly. Okay, right, alright. So when we talk about the any virus, I am not talking about the COVID-19, I am just coming to the COVID-19, but when we talk about the any virus, right, whether it is the infectious virus, whether it is the non-infectious virus, as a whole, viruses, as a whole, virus is technically nuclear protein in nature. This time we are expecting at least one or more than at least one question from this particular discussion what we are talking about. Right? So that's why we are going to cover all aspects of this particular discussion, right? So viruses are nuclear protein in nature, right? When we talk about the chemical nature of virus, it means we are simply talking about viruses are chemically nuclear protein in nature that make a sense of nucleo and protein. This nucleo means what? It's a nucleic acid that could be either DNA or RNA, which is genetic material and then protein. This protein is known as capsid. And this capsid is nothing but it's a covering of virus. It's a covering of virus. Means suppose if I am drawing this as a whole, if I am talking about the generalized aspect of the virus, this virus has the covering of protein, this covering of protein, and then internally viruses consist of this nucleic acid that could be DNA and RNA, and this protein is technically called as capsid. This protein is technically called as capsid. Right? Okay? Are you getting my point? And even at the surface of this capsid or at the surface of this capsid or at the surface of this protein, there is a specific protein like this. The protein itself consists of a number of infectious protein like this. This is what? It's an infectious protein. And this infectious protein is nothing but spike protein. Spike protein. This infectious protein is the spike protein. Fine. Like example, let me show you the example as a coronavirus. Fine. I'm just showing. See, this is the best example of coronavirus. Clear? Let me make you understand. This is the entire covering. This is the entire covering, and this is what? It's a cover protein. Means envelope protein. Envelope protein. Clear? This envelope at the surface of protein. There is also specific categories of the proteins like C. Like C. Look here. These proteins are at the surface of this envelope, and these are infectious protein. And internally you could see here RNA as a genetic material. RNA as a genetic material. Means literally, if you want to simplify this structure, coronavirus that consists of envelope protein, that consists of infectious protein. These two are completely proteinaceous in nature. And then internally, means whether we talk about the envelope protein or the spike protein, this is completely protein, and internally this consists of genetic material as a RNA. So this part is protein, and this part is what? It's a RNA as a genetic material. This is the right. This is a simple representation of any virus. Viruses consist of protein as an outer covering. That itself consists of the spike protein for the infection, and internally it consists of genetic material, and this genetic material could be DNA and RNA. This time we are talking about the coronavirus, where RNA is genetic material. Right? So coming to this coronavirus later on, before coming to this, before coming to this coronavirus, I am just coming to simple representation of this virus, what we have done so far. Right? So let me make you understand here. Virus which consists of protein as a envelope, as a infection. This infection protein is spike protein, and this virus consists of genetic material which could be either DNA or RNA. DNA or RNA. Never. Means either DNA or RNA. Either DNA. If DNA, it means it's a DNA virus, and if RNA, it means it's a RNA virus. RNA virus. Fine? So the best example of the DNA virus that even we are not supposed to know, but I am just mentioning one name here. Like you heard about smallpox. That is the great example of the DNA virus. Clear? You heard about herpes. That is the good example of the DNA virus, right? So these two are uncommon. These two are uncommon, and apart from these two, what you know about viruses, right? Means what you heard about the viruses, means whatever the viruses you know, means whatever the name you heard about, you know about the viruses, we need to put in this category, and here that is the category of the RNA virus. Like here, I'm going to start from the best example as a COVID-19. COVID-19 is not a virus like it's a name of disease, right? I'm going to explain later on. So the COVID-19 virus I'm just mentioning here. Apart from this, what we know about the HIV is the best example of the RNA virus. Polio is the best example of the RNA virus. Zika is the best example of the RNA virus. Ebola is the best example of the RNA virus. Right? Influenza is the best example of the RNA virus. Right? Even, dengue is the best example of the RNA virus. Means usually, even the common cold that is very common these days. Common cold, people are suffering from the common cold nowadays, and they start coughing and sneezing. But now in the panic situation of this global pandemic, they are just thinking about whether this is corona or not, right? So in the case of corona, we also have the similar symptom what is there in the case of common cold, but the people are more afraid about, even in the case of normal common cold, they are afraid about whether this is corona infection or not, right? So just coming to this point, why the people are apprehensive about this corona, that I am just coming to this point. But my point is that here, what you know about the viruses, or what you think about the viruses, or what you have infected right through the viruses. That is the seasonal fever, common cold. These are the classical examples of RNA viruses, nothing else. I'm just mentioning here, the common cold virus is rhinovirus. Rhinovirus. Right? Polio, HIV, Zika, Ebola, influenza, dengue, even H1N1. I'm just mentioning here H1N1, H5N1. We need to discuss a lot. And hepatitis is also the classical example of the RNA virus. And I'm going to make you understand, we have 5 categories of hepatitis, 5 types of hepatitis A, B, C, D, E. And this year, we are also expecting questions from this hepatitis because the Nobel is awarded for the discovery of the hepatitis C. Right? So whether they are going to ask question from the corona, COVID-19, whether they are going to ask question from this hepatitis category of the virus, whether they are going to ask questions from the vaccination program. So these are the different perspectives from where we are going to get this question from this particular topic, what we are talking about. Right? So I hope you are getting my audio visual properly. This is the first class, that's why I am much concerned about the proper delivery of the class. Siddhant, I'm just taking one question. Yeah, Siddhant, I'm just taking a question. Why we don't consider virus as a cell? Because, when we talk about the cell, I will let you know, probably tomorrow I'm going to discuss about the cell. When we talk about the cell is independent unit, and cell has so many organelles inside. Like you heard about mitochondria, you heard about chloroplast, you heard about nucleus, you heard about ribosome, you heard about cytoskeletons, right? So these are sub-organelles inside the cell, and these organelles are responsible for performing different functions independently, right? Fine. So these organelles we are not going to see in the case of viruses. That's why we are not going to consider viruses as a cell, because the cell has so many cellular organelles inside. Either well advanced, well developed in the case of eukaryote, or primitive, developed, is ill developed in the case of prokaryote. But even in the case of viruses, we are not going to see. We are not going to see fine, okay. Hold your questions, hold your questions. Anna, we have just started. Hold your questions. Probably you are not going to ask any question. You are not going to ask any question after the completion of this topic, right? So let me complete first and then you are supposed to ask. Fine? So see here, when we talk about the viruses, viruses are characteristic. Viruses are obligate parasite. Obligate parasite means viruses always requires living host. Always living host is required for the viruses, right? And this host could be plant. This host could be animal. This host could be bacteria. This host could be fungus even. Right, so here when we talk about the host, so this plant is what? It's a plant virus. Like here the best example is the TMV. When we talk about the animal, this is the best example as an animal virus. Host is what? That is COVID-19. In the case of bacteria, this is called as bacteriophage. Right? In the case of fungus, this is called as mycophage. So when we are going to see this term as a PHAGE, phase, when we are going to see this term as a phase, PHAGE, it means we are talking about the viruses. So viruses parasitizing bacteria, that is the bacteriophage. Viruses parasitizing fungus as a mycophage. Otherwise, the normal condition is what? It's a plant virus and the animal virus. And the COVID-19 is the best example of the animal virus. Right? So we need to discuss about a number of diseases, right? Especially in reference to the virus. But here we are supposed to elaborate about the COVID-19. So straight away we are coming to the viral infection. So viruses, there is no specific medication for virus infection. No specific medication for virus infection. Why? Because virus usually affect immune system. Viruses usually affects immune system. Right? So viruses usually affects immune system. That's why the symptom of the viral infections are normal symptom. That is the usual symptom, right? Because the immunity is throughout the body. So that's why the infection is throughout the body. Right? So viruses usually infect or affect human immune system, except the few examples. Except there are so many exceptions. Like see, when we talk about the polio, polio is going to affect your central nervous system. And in the case of polio, there is no death. Usually, polio leads to what? That is the impairment of your limbs. Means polio virus is going to affect that part of the brain that is responsible for the development of the right hand and the legs of the human system. So in that case, in the case of polio, we are not going to get the properly developed hand and the leg. So in the case of polio, usually we are not supposed to get the death conditions in the case of the polio. But that is possible in the case of any virus is going to affect immune system, right? So polio is one example. Again, when we talk about the Zika also affects your brain. Otherwise, when we talk about the viruses, usual condition of the viruses, like example, I'm just mentioning here, viruses usually affects your immunity. Like when we talk about the HIV is the